Hello friends, welcome to our YouTube learning channel Accurate ASME ISO. This channel will help you enhancing your practical knowledge on GD&T and 3D coordinate measuring machine. This video is bringing you a very critical information about applying GD&T controls on the flat surfaces. All the time asked question is flatness or profile. Let us clarify whether flatness or profile for the flat surfaces to be applied. Please do not forget to subscribe the channel and share it to the others. Many of the engineers have confusion that why the profile control is applied on the flat surfaces if already flatness control is available in the standard. In this drawing, profile of the surface control within 0.02 is given. In this drawing, flatness callout is provided on the top flat surface. Then what is the meaning and interpretation when profile symbol is applied and when flatness symbol is applied? And also what is the criteria to select a flatness or profile for the given conditions? We know that datum is not required for the form tolerances. Therefore, datum is not applied to flatness control. Profile controls are with and or without datums. But what the meaning when datum applied to profile controls? It is very important aspect of inspection when only flatness is applied, only profile without datum is applied, and profile with datum is applied. We shall also brief about the inspection of the profile surfaces. Let us quickly recap on the flatness control. The flatness is defined as the condition of a surface or derived median plane having all elements in one plane. This figure shows that all the points or elements are in one plane and therefore the flatness is perfect without having any error. Here another surface shows that all the points or elements are at different level or height, obviously not in a single plane. Therefore, the surface is not flat or having a flatness error. Let us also discuss how the flatness error is defined. Flatness tolerance zone is two parallel planes as shown in the figure. The surface variation between these two perfect parallel planes is called as flatness error. Please note that the first plane of tolerance zone is tangential to the highest points of the surface. The second tolerance plane is parallel to tangential plane passing through the lowest point of the surface. On the shown component here, there are two surfaces at equal heights and with a distance apart. We want to control form errors of these surfaces. There are two aspects of controls available for a designer. One is applying a flatness control as shown here. The symbol 2 into is marked, therefore the flatness of 0.08 is applied to each one of the surface individually. The second option available is profile control of the surfaces as shown in this figure. Here also the symbol 2 into is marked. Therefore, independent surface control of each surface must be within 0.08. Please note that in this profile control no datum are specified. Profile control is without datum is applied. Therefore, profile control is become a form control only. Now the important question is that in these two conditions, what is the difference? Are both of the meanings remain same, as both are the form controls, or there is something else? Let us discuss in next slide. First of all, let us understand about the flatness symbol meaning. We already discussed that the flatness is applied here with symbolic of 2 into, and the reason the flatness is independently applicable to both the surfaces within 0.08. The meaning is shown in this figure. The first surface should be within 0.08, and also the another surface should be flat within 0.08 tolerance zone. However, when examining these two actual surfaces, it clarifies that the first and second surfaces are at different heights, indicating that they are not positioned at the same level or in the same location. Another noticeable point is that the two surfaces are not parallel to each other, indicating that their orientation has not been controlled. However, both surfaces conform to their shape as well as flatness within the same tolerance zone of 0.08. Summarizing, we can conclude that while flatness tolerance is applied to both the surfaces, location and orientation are not relevant. The surfaces are independent of each other in terms of their position and orientation, meaning simplifies that they are not coplanar, they are not in one plane. For the same part, instead of a flatness control, if profile control is applied, let us discuss what would be the interpretation change. Except the flatness symbol in this feature control frame, everything remains same. A flatness of surface is replaced by the profile of a surface symbol. According to the international GD&T standard ASME Y14.5, profile tolerances are used to define a tolerance zone to control the form or combination of size, form, orientation and location of features, and those are relative to a true profile. In this drawing, no datums are provided in the feature control frame. It means that the control is only for the form tolerances of the feature. This indicates that both the surfaces here control for their form variation or the errors. If we read the requirement of the profile in the definition, it is stated that profile tolerance zone to control relative to a true profile. Let us understand now what is the meaning of true profile. True profile is defined by a digital data file or by an appropriate view on a drawing. In the given condition, true profile is a flat surface with the zero offset between them. True profile is also called a nominal profile. The nominal data can be in the form of a digital or in the form of a like CAD model, or as defined it should be appropriately by the drawing view. In this drawing, we clearly visualize that these two surfaces at same level are at zero offset, and therefore digital data may not be required, because the requirement clarifies. We can say that these two nominal surfaces are coplanar, and therefore with the symbol applied of a profile, two surfaces must be coplanar within the given tolerance zone of 0.08. Summarizing, a profile of a surface tolerance may be used to control the mutual orientation and location of two or more surfaces. For basic surfaces that are coplanar, that is parallel with zero offset, a control is provided similar to that achieved by a flatness tolerance applied to a single plane surface. In this figure, we observe that because of the true or nominal flat surfaces with zero offset, a single tolerance zone of two parallel profile planes is created. Each surface shall be within two parallel 0.08 profile planes. Two sets of parallel profile planes are coplanar. Please note that surfaces could be with zero or with offset values. Interpretation of profile specifications applied on the drawing. We know flatness is an individual control. When you want multiple surfaces to lie in the same plane, then Y14.5 standard says to use a profile control instead the flatness control. Also please note that when profile used without a datum, the profile of a surface can replace all other form controls. Let us discuss now when the profile tolerance with datums are given. We already know that profile tolerances are used to define a tolerance zone of form or combination of size, form, orientation and location of a feature relative to a true profile. In this given example, suppose we want to control this inclined surface for location and orientation combinedly with the form tolerance within 0.05 white tolerance zone as shown in this figure. To locate the surface nominal dimension given is 35 from this end of the surface, and to orient it with respect to the axis of the cylinder 105 degree angular dimension is applied. Suppose we want to maintain the inclined surface for location and orientation within the tolerance zone of 0.05, and it would be without the profile control applied. How it would be then? In this case, a designer need to provide location and orientation tolerance separately and to the linear dimension 35 and angular dimension 105 degrees. Even if required, a form tolerances like flatness also be incorporated. Now think it how it become a very critical to divide the 0.05 tolerance into linear tolerance, angular tolerance and the flatness tolerance, and maintain a very precise requirement of 0.05 for the inclined surfaces. All those independent complexities is resolved by applying the profile of a surface with datums for location and orientation controls including the form, and combining all would be a preferred solution of profile tolerance. The surface shall be between two profile planes, which are the flat planes in this condition are 0.05 apart, equally disposed about a true profile that is constructed in translation and rotation at basic dimensions. 35 is the linear basic dimension and 105 would be the basic angular dimensions, and a profile control applied 0.05 with respect to datum A and B, which serves the purpose in a single control of profiles with the datums. Now quickly let us differentiate flatness and the profile of a surface when applied on the flat surfaces. So in flatness tolerance zone is two parallel planes, and in terms of the profile we call profile tolerances zone is two parallel profile surfaces, or in case of the section, two parallel profile lines. The flatness is an independent or individual control, while profile tolerance may be applied to an entire part, multiple features, individual surfaces or individual profiles taken at various cross sections through the part. Flatness is a form control, and any of the form control doesn't require a datum, and therefore flatness also do not require a datum. While profile tolerance may or may not require datum, it is based on the design requirement. When the requirement is a form, then no datum is applicable. When including the size, form, location and orientation is required, the profiles comes with datum symbols. A digital data file defining the true surface file not required in the flatness application, while a digital data file or an appropriate view on a drawing shall define the true profiles. So indirectly we should understand how exactly is the true profile. In case of the flatness, rule number 1 of perfect form at MMC is applicable as a default rule, while profiles do not applicable rule number 1. Flatness can be applied on per unit area, while profile tolerance can be applied on segment or the length areas. Flatness control cannot be used for coplanarity of multiple flat surfaces, while profile control can be applied for coplanarity of multiple flat surfaces, 2 or more. Flatness tolerance is applied to flat surfaces only, while profile tolerance can be applied to any shape of the profiles of the surfaces. Flatness tolerance zone is constant between two parallel planes, while profile tolerance zone can be variable, uniform or non-uniform tolerance zone according to the true profile shape. Hope that you like this video. Please do not forget to subscribe the channel and share it to others. For training inquiry, please find the contact details on the slide. Thank you friends. Take care. Bye for this time. See you soon for the next video. Thank you once again.
I am working in Volkswagen from last 5 years. I had total 8 years experience in different manufacturing industries. From first day I am working in standard rooms and measurement room only. I had work on accurate CMM, Zeiss, Wenzhal, Mutituyo, and I have operated all the types of measuring instrument like roundness, contour, CMM. बट आफ्टर द अकुम ट्रेनिंग जरी मला एक्सपिरियन्स होता एवढ्या वर्षांचा, पण सॉफ्टवेअरमध्ये किंवा बॅकग्राऊंडमध्ये काय चालायचं, कशा प्रकारचे इव्हॅल्युएशन व्हायचे आणि रिपोर्ट आपण कस्टमरला किंवा मशीन शॉप किंवा अजून कुठं द्यायचो, तर त्यामागचा बरेच कॅल्क्युलेशन आज कळाले. प्लस CMMची ॲक्युरेसी नुसती म्हणजे CMM मेकवर डिपेंड नसून ती कुठल्या कुठल्या पॅरामीटर्सवर डिपेंड आहे ते पण आपल्याला अकुम ट्रेनिंगमधून बघायला मिळतं, जे आपल्याला मार्केटमध्ये दुसऱ्या कुठल्या ट्रेनिंगमध्ये PTB की त्यांच्याकडं कुठल्या कुठल्या याचं लायसन्स आहे, स्टँडर्ड जिओमेट्री. ओव्हरऑल ह्या ट्रेनिंगमधून तुम्हाला बेसिकच्या पलीकडचं जे आहे किंवा एक आपण म्हणू शकतो की ऑपरेटिंगच्या पलीकडचं जेवढेही कॅल्क्युलेशन्स आहेत एकदम डीप नॉलेज. आणि मोमीन सरांनी त्यांच्या केस स्टडीजमधून ह्या छोट्या छोट्या गोष्टींचा केवढा मोठा इफेक्ट असतो हे पण त्यांच्या एक्सपिरियन्समुळे त्यांनी खूपच चांगल्या प्रकारे सांगितलं. सो मी खरंच रिकमेंड करेल की ज्यांना CMMमध्ये करिअर करायचं आहे त्यांनी एकदा ही ट्रेनिंग घ्यायलाच पाहिजे. थँक्यू.
नमस्कार, मी विनोद सकपाळ आणि माझे हे सहकारी सुर्वे आणि हुलालकर. आम्ही महिंद्रा अँड महिंद्रा कांदिवली प्लॅन्ट ट्रॅक्टर डिव्हिजन इथे आलेलो आहोत. आम्हाला कंपनीमध्ये सांगितलं फक्त तुम्ही डायमेन्शन आणि मेजरिंग याचं एक ट्रेनिंग आहे पुण्याला, त्याच्यासाठी तुम्ही जा. पण इथे आल्यानंतर आम्हाला कळलं हे GD&Tचं जे ट्रेनिंग आहे. आणि इथे आम्हाला सगळ्यात महत्त्वाचं म्हणजे आम्ही तिघंही क्वालिटी डिपार्टमेंटला काम करतो आहे. आमचे एक सहकारी मेट्रोलॉजी लॅबला तर आणि कटर ग्राइंडिंग या डिपार्टमेंटला टुलिंगसाठी काम करतो. इथे आल्याच्यानंतर आम्हाला कळलं की ड्रॉईंगमध्ये डेटमचं किती महत्त्व आहे ते, किंवा डेटममध्ये काय काय इन्क्लूड असतात, ABC काय म्हणजे काय, त्याच्यामध्ये पोझिशन किंवा सिम्बॉलचा नेमका अर्थ काय, किंवा आपण ते चेक कसं करायचं, किंवा कुठल्या रेफरन्सनी कोणतीही गोष्ट आपल्याला चेक करायची आहे. म्हणजे फ्लॅटनेस असो, अर्गोनॉमिटी असो, तर कुठलीही गोष्ट आपल्याला चेक करण्यासाठी आपल्याला काय करायला पाहिजे आणि ते कशा पद्धतीने चेक करायला आम्हाला मोमीन सरांनी आम्हाला खूप चांगल्या पद्धतीने दाखवलं. जे प्रॅक्टिस व्हिडिओ क्लिप्स दाखवलं त्याच्यामुळे आम्हाला कळलं की कसं चेक केलं पाहिजे. मोमीन सरांची शिकवण्याची पद्धत ही खूप छान आहे आणि आम्हाला सगळ्यांनाच ती आवडली. आणि ह्या ट्रेनिंगमध्ये आम्ही खूप काही शिकलो आहे. आणि हेच ट्रेनिंग आमच्या कंपनीमध्ये पण कसं आम्हाला आमच्या सिनियर्सना किंवा आमच्या ज्युनियर्सना किंवा आमच्या सहकाऱ्यांना किंवा आमच्या इथल्या ऑफिसर्सना पण काहींना हे ट्रेनिंग कसं देता येईल याच्यासाठी आम्ही कंपनीमध्ये नक्कीच आम्ही प्रयत्न करू. थँक्यू.